Perfect. Good afternoon, everybody. Please take your seats so that we can get started. I think you know the drill by now. We have 4 speakers. Each of the speakers has 10 minutes to make a presentation, and after that we have 5 minutes for questions. So if you have any questions, just write them down, and at the end of the presentation we have people in the room who will walk around with a mic. It's very important to speak in the mic so that the people at home who are attending this conference virtually can follow easily. So without further ado, I will present to you the first speaker. Well, I have to say speakers, because we start with a presentation with 2 speakers. We have Leslie McIntosh, who is VP of Research Integrity of Digital Science, an academic turned entrepreneur and founder of Ribita, and she will, together with William White, a health sciences librarian at the University of Wisconsin-Milwaukee, talk a little bit about a taxonomy of scholarly disinformation to enhance research integrity. The floor is yours.
Thank you so much. Thank you so much for having us. So disinformation poses a growing threat to scientific integrity, to public trust, and to healthy living. So to combat this threat, we developed a taxonomy for identifying and understanding disinformation, and we're going to talk through this today. This has been done by myself, Leslie McIntosh, William White, right here, and Cynthia Hudson-Vitale, who is not able to make it. This is the taxonomy of disinformation. I'm sure you can view that just fine. Just kidding. So why create a taxonomy? We create a taxonomy to enable clear identification, quantification, and discussion of disinformation activities and tactics. We want to be able to translate science to policy and provide policymakers with a standard language to develop policies and practice. And we also want to work with journalists to give a structured understanding of improper scientific conduct. And we could not find a taxonomy on disinformation. We found plenty on disinformation that had to do with social media, but we are specifically talking about disinformation that affects scholarly communication and scholarly literature and scholars themselves. To do this, we had many questions in mind, but really what we wanted to do was identify, classify, and understand disinformation. What are the identifiers of scientific manipulations? How do they happen? And some of that we had to really scope and go, well, let's just first identify it. We did this through an iterative process of looking at cases of disinformation that are publicly known, to review them and to come up with what classifications we thought they were, come back, try to put them, articulate them in a sentence to make sense, and then put it together. What we came up with, which seemed obvious in the end, which most things are, it's kind of like a game of Clue or Cluedo, depending on what part of the world you're from. There are the actors. These are who acted, except unlike the game of Cluedo or Clue, it just doesn't have to be one, it can be multiple. So it can be individuals working with organizations and or governments. There are outlets. Where did it happen? Probably not in the conservatory, probably in journals, at events, through media, through institutions. And then the big question of how, and I'm not sure if you can see this, but this is all available. And the how is really looking at deceiving scholarly communications, gaming of mainstream media, and leveraging the judicial system. Things such as lawfare. If you haven't heard, you've definitely heard of the paper mills that was just discussed about lawsuits coming in and taking advantage of the legal system and those costs in order to keep disinformation within the scholarly literature.
So we would like to briefly address the elephant or rat, if you will, in the room of generative AI. So some of you may be familiar with the retracted paper that used an anatomically questionable image of a rat. I think it's even funnier with the censor bar. So this was an instance of using Midjourney to generate inaccurate figures. So this falls into our methods tree in our taxonomy as fabrication. Another instance, we often see a misuse of AI using ChatGPT to write a paper without crediting. That falls under plagiarism in our tree. So AI, is a tool that can be abused, by scholars to create, acts of academic fraud, and our taxonomy accounts for that.
So we looked at cases, again, of known disinformation, and then we took a sample of those to manually do. For some reason, we did 12. We thought we were doing 10. We got a little excited. We did 12. That's how science works. And these are the ones. We're going to talk through 3 cases with you today. The first, Will.
So our first case we're highlighting is an ideal case where you can easily pinpoint the who, where, and how. So Dr. Joachim Bolt was a renowned IV therapy expert, and he submitted papers to well-regarded medical journals with faked data promoting the use of hetastarches to boost blood volume during surgery of critically ill patients. And it was revealed that this actually drastically increased the likelihood of death. And hospitals had to scramble to change their clinical guidelines, which were influenced by his research. So using the taxonomy, this case can be neatly classified as who, scholar, where, journals established, how, fabricating data.
The second one we looked at, which challenged our taxonomy, was Charles Lieber and the Lieber Lab. It's a bit famous, and it is a bit dated at this point, or compared to some of the others, but what happened with Charles Lieber is he did not disclose some affiliations, and in this case, with a perhaps competing, not perhaps, but what the United States considered a competing organization, the Wuhan University of Technology. So for our question with the taxonomy is, does this really belong? And, we weren't looking at espionage. We were looking at disinformation flowing through science, but realized what we needed was in the where category is that we needed to look at institutions, but also governments, that governments could not be excluded for, unfortunately, moving disinformation through the scholarly literature. So in this case, Charles Lieber is a scholar working at an institution and with the government, and he concealed affiliations and/or political ties.
So our last case that we're highlighting poses a challenge for our taxonomy, which is, what do you do if you don't know one of the categories? So a hoax paper was accepted by Higher Education Quarterly that used fake statistics and was purporting right-wing donor influence to universities. And the authors used pseudonyms whose initials spelled Sokol 3. This was an homage to an infamous hoax paper in the 90s that was parodying and critiquing cultural studies. And so this Sokol 3 paper was reported by several conservative news outlets as an example of woke bias within academia. And so because the authors adopted pseudonyms and they never publicly revealed their identities. We can't pinpoint the who. We don't know if these were disgruntled academics. We don't know if these were political actors. And so this kind of blurs, the line between, activism or active measures. And, this is kind of the point of disinformation, is that intent gets blurred. And so our taxonomy is helping us focus that question to intent and to help us identify the gap in our knowledge.
So our future interests are, well, if we put this out there, how can it be gamed or misused? If a person would like to say that something is disinformation, then pick out the pieces and say, see, you have a taxonomy. This this is disinformation. What do we do? So we're looking at testing that. What is the difference between academic disagreement, questioning, and disinformation? How can we steer policy recommendations? That's really Cynthia's cup of tea. And then what are the aggravating motivations, motive why, which we really didn't concern ourselves with. So thank you, and I think we're ready for questions.
Perfect timing. Thank you very much. Yes, so now we have 5 minutes time for questions. So feel free to raise your hands. I can already see one at the back of the room.
Sorry, I've got the microphone over here already.
Over there.
So my name is Maria. I'm with PLOS, the Publication Ethics team, and I also work on the NISO COREC group for communication of retractions and expressions of concern. And obviously a taxonomy is something that we've discussed over at the COREC group. We decided to not include it as a required item on notices, because in the end, journals do not have the jurisdiction to adjudicate on misconduct. We are very dependent on institutions giving us the information. Now, often universities either do not share information with us at all, or when they do share it, it's confidential and we cannot publicly share it. And our concerns are that if you have an article that is being retracted, but you do not include a notice that it's been misconduct, even though you know it is, people may then interpret it as in there has been no misconduct here simply because we are unable to publicly share that information. And so my question to you is, what would you do to prevent the taxonomy being used in a way where people will infer no misconduct simply because we haven't been able to share it, not because it wasn't there?
Thank you for that question. I also have a poster here on a taxonomy of retractions, and I think this goes nicely with the two of them. I personally believe that this has to be a third party that works together independently as in a polite term of the word honest broker for this information, so that we can both have it and understand it and also trust that information, and then work with communicators who understand how to communicate that better to the public.
And, unfortunately, we can't really rely on, universities to police their own researchers, when they commit academic dishonesty, because universities, they want to protect their own image. So I agree with your solution.
Hi, Ali Jackson, UTS of Sydney. Yeah, this is cool. Have you done like more, maybe you're going to do it, but more extended mapping whereby you can almost then predict related to fields or certain types of fraud that they've taken a certain route through the taxonomy and will end up in a certain place, so that you kind of can do a bit of crystal ball gazing?
Thank you for that question. The answer is, this is the first time we've presented this taxonomy, so we wanted to get feedback and a little bit of information before we started collecting that type of data. And I do work for a company, Digital Science, that has Dimensions, that has a lot of data, so I will be probing that, and hopefully by the next one, you will see more of the data coming out of looking prospectively at the information of being able to predict. But right now, no.
Hi, this is Lisa Rasmussen, UNC Charlotte. I'm sorry if I missed it, but did you define disinformation?
I think that we actually missed that when we said that. Will, do you want to define it?
So I would define disinformation as false or misleading information that has intent behind it. So, misinformation is kind of a more ambiguous term that refers to, false or misleading information regardless of intent. But with disinformation, you have that intent.
So there's an interesting question with things like the so-called type hoaxes that is markedly different from other kinds of misconduct results. And so I'm wondering if you're thinking about what you do with the information out of a tool like this taxonomy that would go in one direction, would ask whether you have to put a misconduct label on it or send it off to someone. Our third party is going to look at this and they decide what to do with the information, because as problematic as some of the so-called hoax papers are, they're trying to get at something that we should be talking about in a different way than misconduct.
I would say that one the so-called hoax, in fact, brings up a lot of questions on this, because if you believe that they are scholars who had the true intent of exposing a weakness within scholarship, that works. But we don't actually know. Some people think they know. If we know, that's a different story, but we don't know. They've not come forth. They could be working with an organization to put forth disinformation, to act like a scholar. Now, the whole reason there's a couple of reasons we stuck with disinformation. Partially, I went to Nobel Prize winner Maria Ressa speak, and she said we need to be using disinformation. It's stronger. It is what we need to be talking about. Probably when it comes to tagging information, it'll be misinformation because there'll be less lawsuits on that. So there's the reality of that.
Okay, thank you. That's unfortunately all the time we have for questions. So thank you very much for the speakers. And we will immediately go to our second speaker of this session. Jeremy Nielsen is a research assistant at University Monash, and today he will talk about authorship. So again, the floor is yours, Jeremy, for the next 10 minutes.
Thank you, and thank you everyone for coming. Today I'm going to be talking about the approach that we use as part of the MOL group to systematically assess papers that we think are problematic. So we call this post-publication peer review. So essentially these are papers that have slipped through peer review and are problematic. They exist in the literature. We're interested in clinical trials in obstetrics and gynecology. And so our principal concern is that these trials existing in the literature are included in evidence syntheses and that they're then altering clinical practice. So why do we need them? As some background evidence, there's quite a famous paper from Carlisle a couple of years ago who investigated 526 articles submitted to anesthesia and analgesia. 14% of those he considered contained false data and 8% were fatally flawed. He called them zombie trials. For trials that provided individual participant data, 44% of them had false data and 26 were zombie. Ioannidis, in an accompanying editorial, says that based on the number of trials registered in clinical trial registries around the world, this amounts to several 100,000 flawed trials circulating in the current literature. And we know that these results are directly affecting the results of evidence syntheses, which in turn directly influence clinical practice. The second part of our argument is that once someone falsifies a trial or alters the results or what have you, we know that they tend to do it more than once. So this is the Retraction Watch leaderboard, which I'm sure some of you are familiar with. The top 10 all have almost 50 or more retractions, which is a significant number, and you'll notice that most of them are doctors working in clinical trials. This has been quite extensively published on by us and others. And so what's the approach? What do we want to do? The aim is to develop methods, to combine methods to assess the work of one author or author group systematically and all at once, so that if we find an author who has existing retractions or existing concerning papers, we then go forward with a high index of suspicion for the rest of their work and see if we can identify any other papers that might be distorting the literature. So what does this look like? In our hands, we start with a systematic search of everything that an author has done, followed by a high-level comparison, both statistical and bibliometric. We then assess individual papers one by one and apply methods that I won't talk about today because of time constraints, but they closely follow the tracked checklist, which you can search up in your own time. And then we report findings to journals, publishers, and to the general public. So how do we identify papers? This is quite standard. We use PubMed and Google Scholar. PubMed indexes quite a large number of articles. Google Scholar is better at identifying articles that are not indexed in higher impact. So lower impact factor journals, local journals are often not indexed on PubMed. And we use the Publish or Perish app, which is quite convenient if you want to download the results of Google Scholar search. You can then identify retracted articles, editorial expressions of concern in the Retraction Watch database, and unpublished studies, because again, we look at clinical trials. If you want to identify unpublished studies by a particular author, we go to clinical trial registries. And we identify clinical trial registries during the search process. So we use the registries that we know an author publishes in. And then you extract the data, and a basic extraction looks something like this. So each study has an ID in the leftmost column, followed by what is mostly basic bibliometric data and study outline data. Importantly, from that we can generate study timelines. So the grey bars are the start date and end of follow-up for each of these trials. Each trial is on a separate row. The red boxes are the date of registration, and the blue boxes the date of submission to a journal. And so this graph tells us a couple of things. First, it allows us to identify retrospectively registered studies. Now, retrospective registration is not a problem in and of itself. Things happen. Sometimes people haven't registered prospectively. For older trials, it's not as common to register prospectively, but it does raise your index of suspicion that a trial might be methodologically incomplete. We can also identify studies where the submission date to the journal is too close to the end of follow-up. So for instance, that bottom one there is very, very soon. You would expect a couple of months for data analysis. And the top one, it's been submitted before the end of follow-up, which is obviously impossible. We then extract results. We have a very convenient spreadsheet which you can access online that allows us to extract baseline characteristics and results and recalculate p-values, which I'll talk about again in a bit. We then apply to a set of studies Carlisle's method, which was designed by Carlisle for use on randomized controlled trials. And it works on the assumption that if randomization has been conducted correctly and the null hypothesis is true, that is that two randomized groups will not differ statistically in baseline characteristics, then the expected p-value distribution for combined p-values across trials should be uniform. And so that's the linear slope there is what the distribution should be. The two dotted lines are the combined p-values from trials by the fabricators Fuji, the red dots, and Saito, who worked with Fuji and was later investigated by Carlisle, in the black dots. And both of those are significantly different to the linear distribution. Traditionally, this method only applies to continuous variables. More complicated techniques are now available to do categorical variables. Another statistical approach which hasn't, to my knowledge, been used, but we're interested in using it and do use it occasionally, is the Newcomb-Benford law, which basically states that the expected distribution for variables changes based on the position within a number. So if you look at the table on the left, you would expect that for the first digit, 1, 2, 3, 4 have much higher probabilities of occurring than higher numbers, up to 9. And then as you get further away from the leading digit, you approach a uniform distribution. And you can see on the right, this is a basic Z test comparing the distribution of values in trials by a niece to Scott Rubin, who had 21 papers retracted. And you can see that they differ significantly from the expected distribution. And then we get down to looking at individual trials. And one of the first things that we do is we compare trials by the same author on similar topics, because we find that data copying is quite common. and can be quite a red herring, if you like. And these are two examples where green dots are identical values and red dots differ by plus or minus 1 for any digit. Using the table that you saw before, we also recalculate p-values. Incorrect p-values are, again, not necessarily an indicator of misconduct, but they are certainly an indicator of poor methodology, poor data analysis, and can indicate further problems. If, for instance, as you can see there highlighted, they change the statistical significance of the results, that's something that needs to be corrected at very least. And we've applied this approach to numerous authors, and you can see that techniques do differ between authors, but largely we do pick up results on multiple statistical checks, and you can see that a large number of studies are retracted or have editorial expressions of concern as a result. And then comes the most important part. Of course, this method is merely a suspicion-raising exercise. So all you can do after all of these checks is to say that we have a high index of suspicion that this study may be methodologically unsound or potentially fraudulent or fabricated. Of course, the only people who can make that decision are the journals and publishers. So that's a formal investigation. For single studies, usually we would begin by contacting the authors. You can also publish on PubBear or contact the journals and publishers directly, which is always a component of this process. For groups of studies, which combines the techniques that I've been talking about today, we recommend peer-reviewed publication as a neat way of sort of forming a data repository online that people can access. If you have a blog, then blog posts also work. And again, contact the journals or publishers involved. Unfortunately, responses are very slow, very inefficient. And so if you do go forward with investigations of this sort, be prepared for it to be sort of the long haul. But like you can see, we do get results. These methods do work. And journals and publishers, although slow, do eventually come around a lot of the time. And of course, thank you for listening, and thank you to quite an extensive network of collaborators who've contributed to these techniques.
Thank you. Any questions from the room? I see one in the back.
Yeah, thanks a lot. Thanks a lot for your presentation. And first of all, thank you. Thank you for doing such great work. I think this work is really needed. And I guess this kind of large-scale flagging and eventually cleaning of the literature can be more impactful than producing 2 extra papers. So thanks a lot. I wish more people would do as your group does. However, I do have a question. You said rightly at the end, what you do is merely flagging, although you are quite sure there has not been a right of reply, so there is a need of a formal investigation. But the responses are lagging, are slow, are sometimes inexistent. We tend to try what we can, but what is the role of institutions you think that they can do better next to journals and perhaps national offices where they exist?
Yeah, so that's an interesting question, especially for cases where there's quite extensive problems. So say you have an author with 10, 20, 30, 40, over 100, for example, studies that are problematic. It's very difficult to get through those studies by going to journals and publishers individually, because of course those studies might be spread out over 50 journals and 5 publishers, 6 publishers, 10 publishers. And it's very difficult, of course, to get publishers to work together for privacy reasons, what have you. It does make sense. So the ideal approach, of course, is what COPE recommends, and that's to have an institutional investigation. But institutions, like William said, are unwilling or unlikely to investigate their own authors unless quite strongly pressed. And so there is a roadblock there. I think it's not an easy fix. it's probably a cultural change that's required, a greater focus on integrity over the perception of an institution, perhaps. You could talk about policy solutions all day, but I don't think any of them would be perfect.
In your experience, Jeremy, who would be best placed to kind of coordinate this kind of approach?
In an ideal world, we would like to see journals and publishers working together. It is beginning to happen. Journal editors in particular are beginning to take on investigations systematically and together, and there is a history of doing so, but traditionally that approach is backed up by an institutional investigation. Like I said, an institution is the ideal place for this kind of investigation, but with the current levels of transparency and willingness that we see in institutions, I think it's probably best with the journal editors and publishers.
It's Katrina McCallum-Wiley. I'd just like to echo what great study you've done. I led the project to get rid of Hindawi's. We've done about 11,000 retractions over the past year and so. Large fraction of those were actually clinical trials in which the ethics weren't reported and other things. What I'm interested to know is what are the consequences, ultimate consequences for these authors? Because by the time the investigations are done, and inevitably they take time, even when you do fast-track retractions, the authors concerned have usually got their position or promotion, and it's not clear there are any lasting consequences. So I'd just like your views on that. Thanks.
I think, from my perspective at least, consequences for authors are somewhat secondary. I mean, the priority is the accuracy of the literature, especially with clinical studies. And so retraction is our primary concern, or at the very least an expression of concern, so that these studies are then not included in future systematic reviews, meta-analyses, practice guidelines. As a deterrent, consequences for authors is a nice idea. If an institution does investigate, then often authors will lose the privileges that they've gained from their research. They'll often lose their positions as well. But that doesn't always happen. Sometimes authors do go on as normal, just without publishing or finding it very hard to publish, or publishing in smaller journals, so on and so forth. I think to make a grand statement about punishing authors is a bit difficult, given that a lot of the time maybe one or two authors are responsible for misconduct and the rest of them are students or associates who don't know that they've been included or are afraid to speak up and so on and so forth. And there are many cases, especially in the biomedical sciences, of people who've had their careers ruined because their supervisors were exposed for academic misconduct, and subsequently they, as early career researchers, couldn't be hired, lost career advancement and so on. So I think punishment is best handled by institutions who can determine who is responsible and who's not. And again, that requires an institutional change of practice.
Okay, thank you. I'm afraid that's all the time we have for questions. So I would like to invite Barbara Lancho Barrantes to the stage. Thank you, Jeremy, for your talk. So Barbara is a senior lecturer in the School of Architecture, Technology and Engineering at the University of Brighton. Okay, the floor is yours, Barbara.
Thank you so much. Good afternoon, everyone. My name is Barbara Lancho Barrantes. I am a scientometrician. My background is in bibliometries. I'm delighted to be here presenting my work, Citation to Questionable Journals, Threaten Research Integrity. Bibliometries as a key actor in the detection. The contribution of this research is to demonstrate how we can use bibliometries methods to trace citations to questionable journals. The rise of digital publishing and open access publishing has provided researchers enormous benefits. For example, to increase visibility, increase impact, increase citations. However, questionable publishing has been an intended consequence of the rise and success of open access publishing based on an author-paying business model. However, the problem of publishing in questionable journals goes beyond. So researchers are citing papers published in questionable journals. This is called citation contamination. It happens when researchers cite articles published in questionable journals. Citation contamination is a threat to research integrity as it can lead to disseminated, potentially flawed, fraudulent, and plagiarized research. Results of studies show that researchers are citing articles in questionable journals, as a result, potentially contributing to the problem of questionable publishing. This study aims to illustrate how researchers who publish in mainstream journals that are included in mainstream citation databases are still citing questionable papers. So citations are adopting different shapes in the context of questionable publishing and research integrity. For myself, as a bibliometrician or cytometrician, whichever you feel better, citations are citations. So, but some scholars like to name them. So we can find in the literature different types of citations. So coercive citations, citation contagions, gift citation, honorary citations, citation clubs, citation cartels, over citation, citation inflection. And this is only an example and sample of the different shapes that citation can have at the moment. So my work is under the citation contamination, but as I said, there are other types of citation currently happening. But what are the main research questions of this study? So how many publications included in citation databases are still citing questionable journals? What scientific discipline do they belong to? Which countries have the highest concentration of citation to these journals? Do these publications have a high impact? Do they involve international collaboration? So in order to do the analysis, we use the directory of open access journal, DOAS, is a highly regarded reliable database of open access journals. So so DOAS classified the journal. So when the journal no longer comply with the good practices in the directory removed the journal from the list. So we chose the journals excluded from DOAS in the course of the year 2018 for suspected misconduct from the publisher. In 2018, DOAS removed a total of 57 journals. The exact time and the reason behind they removed was not declared. We examined the 57 journals, and we only selected the one with the unique title and ISSN. So out of 57 journals, we only chose 21. So we employed a Scopus database. So we examined the number of documents that were included in the Scopus database and were citing these 21 journals that were removed. So we expand the citation window. So we identified the documents included in Scopus in 2018 to 2021 to give time to recruit the citations. So we identified a total of 15,268 articles, reviewed conference proceedings included in Scopus publishing in journals indexed in Scopus that were citing these journals that were removed from the Act in 2018. So we analyzed the citation behind this, so we applied bibliometric indicators, and for that we use Cybal as an analytical tool that, because belong to, well, so use data from Scopus, so to be a bit consistent with the tools. Oh, sorry. See here. So here is a schematic diagram. So how we did the experiment. It's just for you to see how we did it. So we selected the journals in DOAT, the 21. So, and we identified the papers which cited these journals in Scopus, and then we applied indicators from Cybal. So this is one of the results that we found. So so this publication has almost 20% of international collaboration. So these 15,268 had some international co-authors in the papers. And we can see, well, we can see in the table, the overall, and also in the different columns, we can see the split indicator, if you want to see in more detail. So this publication obtained a field weighted citation impact of 1.02, is an average of the same kind of discipline, the same period of time, and the same type of documents. 10% of this publication were in the top citation percentiles, which is good. And also, 9% of this publication were published in top journals percentiles. We can see that this publication, so the highest score in the indicator were in 2021. Could be nice to investigate a bit more, so we can investigate why this publication in 2021 obtained the highest bibliometric indicators. Could be interesting. As you can see in red, that, yeah, they has highest indicators. So the table 2 shows the type of journals where these publications were published. So we can see that the majority belong to the second quartile of impact and third quartile of impact. And they belong to... 1 minute. Oh, sorry. And goal open access. So the publication belong to the countries, Iraq, Morocco, and Algeria. So the subject areas that they belong to: engineering, computer science, and mathematics, no medicine. So a matter of conclusion, we found 15,268 outputs between 2018 and 2021 in Scopus. Almost has 20% of this publication in collaboration. Well, as a researcher, we must be aware of any potential citation to questionable journals. Peer reviewers and journal editors play a crucial role in the publishing process by acting as a primary checkpoint in the detection of these issues. After this analysis, DOAS no longer uses the label suspected misconduct from the publisher. I emailed DOAS to ask why they decided to remove this label. So instead, the journals previously belonging to this category are now in the label journal not adhering to best practice. The reason behind that is because they decided to start using a more neutral reason of not adhering to best practices. I think they receive a lot of complaints from the journals, and it's aligned to the policies on rejection. Thank you for your attention. Thank you so much.
Thank you, Barbara, and sorry for interrupting so rudely. I always feel bad when I have to be very strict on time. But yes, any questions? We have less than 5 minutes, actually. So if there are any short questions, that would be very much appreciated.
Thank you for your wonderful presentation. Because you're at a university, how are you working with this information to look for policies or interventions perhaps at your, or are you looking at your university to kind of combat this contamination, or what are some solutions, I guess?
It's a good question because I recently moved jobs. So my institution at the moment is, I don't know, is building a bit of the knowledge on bibliometries. So I think we need to create a bit more awareness and training for researchers to, I think the university at the moment is in early days to, with this type of topics. But definitely, I think I see an area that the university could grow on this and do. Thank you.
Thank you. I propose that we go to our last speaker. Thank you, Barbara.
No worries.
And that is Vasily Vlasov, who will be talking about reporting on the activities of the DISCERnet.
Thank you, Stephanie.
Welcome, Vasily.
Dear colleagues, may I direct your attention to the large number of authors of this presentation. It is because we are quite big organization, but our organization don't have formal membership, not registered, not have bank accounts, only 4 founding fathers represented in public. This form of organization was invented 15 years ago, and it helped us survive in the acid waters filled with crocodiles. Our objectives from the very beginning was not just to check dissertations for plagiarism. It was about the ethics and quality of science. No, but the first efforts were directed to the dissertations, and it was tightly connected to the progress in accessibility to the electronic versions of dissertations. And you see that we mined 13,000+ plagiarized dissertations. We mastered to write 2,500 complaints to the Ministry of Education and Science, who manage the scientific degrees, candidate of science, and doctor of science. And it is a huge work because these complaints should be very detailed in description what is plagiarized and what was falsified. And see, the outcome is quite good. More than 60% our complaints led to that people were deprived from their degrees, from candidate and doctor of science. It looks like our short presentation of cases on the website. This doctor had actually carbuncle, we say, after Sherlock Holmes, carbuncle dissertation, which is plagiarized from another text. And many of such people who plagiarized lots of text frequently connected to fabrication, or they plagiarized dissertation from the meat production and create in this text the chocolate production. Retain the numbers, retain the words that change the meat to chocolate. Unfortunately, it's not an exception case, it's quite a typical case. First years, we directed important groups of our society. Here you see the chairs in Russian parliament. Red are members of parliament deprived their scientific degree and PINC are under consideration. It is 2016. Since then, the members of parliament became smarter to defend themselves. Another group of subjects we studied specifically rectors of universities, of all institutes of higher education. It's an example, rector of one of the biggest universities in Russia. Unfortunately, our findings in relation to rectors almost never led to dismissal of these people. So you may imagine what is the ethics of these higher education organizations. We publish reports on specific subjects like rectors of Russia or specific aspects of the data manipulation like empirical data manipulation, or we studied the candidates of the Academy of Science in 2020 and helped Academy of Science to elect only good people, at least not plagiarizers. Because we have a huge volume of work, you see we were able to weight different sciences. And we see that in biology, physics, mathematics, almost no plagiarism, and medicine, social science, and economics is blossoming enormous number of plagiarized dissertations. Yesterday in this room, Anna Balkina reported about her new work of hijacked journals. Years ago, she did a great job connecting cases of plagiarized dissertations with institutes and dissertation councils. And of course, they are not random in between scientists. It is connected specifically to specific directors, to specific dissertation councils. It is evil network. The same presentation of data is here. Again, it's concentrated near the nest of evil. Of course, we improve our detection methods, but plagiarizers and fabricators invent new tools to evade from detection. For example, in numerical data, nowadays plagiarizers copy the original data and correct it. And we still have problems with analyzing this data. But anyway, a couple of people lost their degrees because we proved that these data were manipulated. And we moved a lot from dissertation to journals, first to Russian journals, next, again, it's connected to the beautiful new translation software. We moved to international field, to international catchment areas, and find plagiarism from Russian to German, from German to French and Chinese. It works. It works. You see that after 2013, actually, most cases are journal cases. We retain our name, DCERNet, but we move to journals. Of course, it is connected to the press to publish, which is well known. We all here work under this pressure. But it is what is new in our more than 10 years work.
1 minute.
Of course, we have still the problems connected with images, which is difficult to detect automatically, and we were quite successful in detecting the articles fabricated and authorship sold on the market. We cover mostly Russia, but countries of former Soviet Union and nearby countries are involved in our analysis too. Today we listen to the report of wonderful whistleblower analyzing the misdeeds in the women health research. We believe that despite glory of whistleblowers, we need the systematic process of detecting of research misconduct and exposing it. Detect and expose. It is what we think have to be done systematically. Thank you for your attention.
Thank you, Vasily. Any questions? No.
Oh, it's quite clear.
That could indeed be the case, yes, very much. I do still have a question. I was wondering, you raised attention to the difference in plagiarism numbers between disciplines, and I was wondering if you have any kind of explanation towards where these differences come from, considering that they all work in the same Russian context.
On the left, the hard science. On the right, soft one. Humanitarian sciences, economics were suppressed Soviet time. So there was no good schools, no good research schools. So they are just doing what they can imagine. Medicine is spoiled a lot. For example, in medical dissertations, we don't pay attention to literature review at all. Because if we look at plagiarism in the literature review, it will be 50% of all dissertations. Just literature review is just copied from dissertation to dissertation.
Yeah, okay. I'm checking to see if anyone raises any hands. I think there is in the middle.
Hi, thank you for the great talk. Jack Wilkinson from the University of Manchester. I'm just curious, so you mentioned that you check for plagiarism of numerical results. I was wondering if you could explain a bit about your method for detecting plagiarism of numerical results. And I'm curious, does that extend to detection of plagiarized tables also, or just sort of numbers in line? Thank you.
First, we did look just for text plagiarism. On the first view, it's quite simple to detect similar numbers. But in reality, it is not that simple. So we start to do it only last five years. And from the very beginning, we find out that tables is difficult to analyze. The image recognition, because we have to scan dissertation and recognize the images, it involves the differences between artificial differences. And most important problem is that when people copy the data table, they change some numbers. So we employ the algorithms to find the so-called human correction of data to detect. And of course, after that, it's by human eye. Human eye is the most reliable instrument. And Elizabeth Big,
Thank you, Vasily. All right, I think our time is up. I have one favor to ask of you, the audience. I would like an applause for the technical staff and for the people going around the room with the mics for this very smooth and professional organization. Thank you very much.